Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our first video on this newly launched YouTube channel under title Electronics by Rajput Abdul Bari Bhatti. In this video we will solve three problems of electronics. All these three problems have been chosen from the book Fundamentals of Electric Circuits by Charles K. Alexander and Matthew N.O. Sadiq. Okay. First we come to statement of first problem. Okay. How much charge is represented by 4,600 electrons? Quite simple, very easy. Dear students, this is a table of various physical constants in which in second row electronic charge E is given as being equal to 1.602 into 10 raised to the power minus 19 coulomb. Okay. Sometimes this charge is also denoted by small q. Okay. Sometimes this electronic charge is also called elementary charge. Okay. Anyhow, no difference whether we call it electronic charge or elementary charge and whether we denote it by small e or small q. Its value is so and so coulomb. Okay. For the time being, we do not go in detail of definition of coulomb. In some other problem, when it will become more relevant, then we will also discuss the definition of coulomb. Okay. So this second row physical constant, that is electronic charge or elementary charge, small e or small q equal to 1.602 into 10 raised to the power minus 19 coulomb, indicates that this is the amount of charge on one electron or one proton, because we know that charge on electron and proton is exactly equal in magnitude but only difference in sign. Electron carries negative charge and proton carries positive charge. Proton is a very massive particle due to which it remains inside the nucleus, while electron is very light particle, so it revolves around the nucleus. Okay, so dear students, quite easy problem. We see that one electron carries so much charge, then definitely so many electrons will carry so much charge multiplied by this number 4,600. Okay, quite easy. Charge on one electron is equal to minus 1.602 into 10 raised to the power minus 19 coulomb. Okay, because here electron is under consideration, so we will take minus sign. If proton is under consideration, then we will not take minus. Okay, then it will be positive. Charge on one electron is equal to minus 1.602 into 10 raised to the power minus 19 coulomb. So charge on 4,600 electrons is equal to minus 1.602 into 10 raised to the power minus 19 into 4,600 coulomb. This alternatively becomes equal to minus 7369.2 into 10 raised to the power minus 19 coulomb. We can change this figure as per our discretion to minus 736.92 into 10 raised to the power minus 18. Okay, this 10 raised to the minus 19 has been converted into 10 raised to the power minus 18, but decimal has been shifted one step backward. Okay, in the next step we have repeated the same process and it has taken the shape 10 raised to the power minus 17, and decimal has been shifted one step more backward. In the next step we have repeated the same process and it has taken the shape as 10 raised to the power minus 16 column, and decimal has been shifted one step more backward. Okay, so our answer becomes a charge on 4600 electrons is equal to minus 7.3692 into 10 raised to the power minus 16 coulomb. Okay, second problem is also quite similar. Calculate the amount of charge represented by 6.667 billion protons. Okay, dear students, here we will not take minus sign because here electron is not under consideration, proton is under consideration. However, the term billion is slightly inappropriate, perhaps inappropriate. Actually, the term billion does not basically belong to physics. It belongs to accounts, accounting and finance, etc. Okay, but we are bound to consider this term billion. Okay, actually, dear students, in physics there is an alternate term giga in place of billion. Okay, giga means 10 raised to the power plus 9. Nano means 10 raised to the power minus 9. Giga means 10 raised to the power plus 9. Okay, so this billion is also equal to 10 raised to the power plus 9. So in other words, we can say that it is equivalent to giga. Okay, so anyhow, charge on one electron is equal to plus 1.602 into 10 raised to the power minus 19 coulomb. Charge on so many protons equal to this into this multiplied by this, and this becomes equal to the 10 point this and this into 10 raised to the power minus 10. Now we convert it into 10 raised to the power minus 19 minus 9. For this reason, decimal will be shifted one step backward. Okay, so its answer will become 1.068053 into 10 raised to the power minus 9 coulomb. Okay, 10 raised to the power minus 9 can also be said nano. Okay, so it is equal to nano coulomb. 1.068053 nano coulomb. Okay, it is our discussion whether we call it nano coulomb or 10 raised to the power minus 9 coulomb. Okay, problem number 3, determine the total charge entering a terminal between t equal to 1 second and t equal to 2 seconds if the current passing the terminal is I equal to 3t square minus t ampere. Okay, dear students, this portion has been provided in the book as a guideline. Okay, so we will follow these guidelines. Okay, electric current is the time rate of change of charge measured in amperes. A mathematically the relationship between current I, charge Q and time t is I equal to dq over dt. Okay, dear students, here above sign of equality there is a delta sign, del. For the time being, we leave it for some future time when we will be in a better position to explain why it is written so. That sign of equality is below and its upper side del comes. Okay, del or delta. The charge transferred between time t naught and t is obtained by integrating both sides of equation number 1. Okay, that is q, capital Q equal to t naught to t I dt. Okay, this is just a guideline provided in the book. Okay, we will follow these guidelines. Okay, so according to these guidelines, our solution becomes capital Q is equal to t equal to 1 to 2 I dt. This becomes equal to 1 to 2 3 t square minus t dt, which is given in the statement. Okay, when we integrate, this t square becomes t cube, t raised to the power 3, but at the same time it is divided by 3, and that 3 will be cancelled with this 3 and only t cube will be left, t3 minus. Similarly, t power of t will be increased by 1 and at the same time it will be divided by the same quantity. Okay, so it will become minus t square divided by 2. Okay, moreover this sign of integral from 1 to 2 will take the form as, okay, from 1 to 2. Okay, first we will put 2, then we will put 1 and in between it will be minus. Okay, so when 2 raised to the power 3 will become 8 and 2 raised to the power 2 will become 4. 4 divided by 2 will become 2 and hence 8 minus 2 minus. When we will put 1 it will become 1 and minus 1 by 2. So this 8 minus 2 equal to 6 and this half can also be written equal to 0.5 and hence our answer becomes equal to 6 minus 0.5 equal to 5.5 coulomb. This is the end of our first video. Till next video, Allah Hafiz.